So if we know the zeros of a polynomial, we can then factor it using those zeros. Now there's this thing called multiplicity. You've seen with quadratics we have repeated roots sometimes. Well, you can have a root repeated more than once, and that's what we call its multiplicity. So in this example, we have 2 is a zero of this polynomial, 5th degree polynomial, and has multiplicity of 3. We want to fully factorize. So what we know at this point is that x minus 2 times x minus 2 times x minus 2 times 2 other factors are going to give me f of x. So we need to find those other zeros, we need to find those other factors, and what we're going to do is we're going to use synthetic division 3 times to hopefully get down to something that is a quadratic. So here we go. We're going to put the 0 on the outside, and then our coefficients 1, negative 4, negative 3, negative 34, negative 52, and 24. And we're going to go through the process of synthetic division. Pause the video right now and try to work through this on your own. Okay, so here we go. Let's see how you did. We bring the 1 down, multiply outside, then we add, then we multiply, then we add, then we multiply. That should have been a positive 34. Hopefully you caught that. 20, and then we have 40, negative 12, and we better end up with 0 as the remainder. If we don't, that means that that isn't a 0, but since we were told it's a 0, if we don't end up with 0 here, we made a mistake somewhere. So what we now know at this point is x minus 2 times x to the 4th minus 2x cubed minus 7x squared plus 20x minus 12 is equivalent to f of x. I'm going to synthetically divide again on these coefficients using another 2. So we drop the 1, 0, negative, that'll be 0, negative 7, negative 14, 6, 12, and again we get 0. So here, let's pause for a second and realize what this means. We now know that x minus 2 times x minus 2 times this depressed polynomial, x cubed plus 0x squared minus 7x plus 6 is equivalent to f of x. But we know that we can divide one more time by x minus 2. So we bring the 1 down, we have 2, 2, 4, negative 3. So now we're in a really cool position. Now we have established that x minus 2 quantity cubed times x squared plus 2x minus 3 is f of x. Well, notice that's a lowly quadratic. We know what to do with those. We try to factor. We don't need to know the zeros to factor those. We've been doing that for a long time. X plus 3, x minus 2. There is my fully factorized f of x polynomial. Now, in the quadratics section, we saw and derived the product and sum of roots. There was another way to calculate the roots from the polynomial. And we can extend this idea, and this idea has been extended to any polynomial where we have an times x to the n plus blah, 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 plus a1x plus a0, where the coefficients, the ak's, can be real or any complex number with the leading coefficient not equal to 0 and these zeros. Then, the sum of the roots is equal to the opposite of a sub n minus 1 divided by a sub n. So using some words, leading coefficient is on the bottom and opposite of second coefficient. And the product of the roots is equal to negative 1 to the n times a sub 0 divided by an. So sometimes this product will be negative, sometimes it will be positive, and it depends on the degree of the polynomial. Degree even, product is positive. Degree odd, product is negative. And using words here again, it's the constant divided by the leading. And these are the same formulas that we saw back in the quadratic section. And they're fairly simple to apply. It's just a matter of remembering these. It's one more tool that you have for dealing with polynomials.